All right, good afternoon. We move on to the next part of progression. Is still under geometric progression. Okay, so finding the sum to infinite, okay, of a geometric progression. Okay, now if you recall back, under sum of geometric progression, there's actually two types. The sum, you got two formulas. One is when r is greater than 1, the other one is when r is less than 1, right? Okay, so now when r is less than 1, the formula for your Sn is a1 minus r to the power n minus r. Okay, now let's assume this formula. We make two assumptions. One is when n approaches infinite, means here your n is actually increasing to a very, very, very big number. Okay, whereas your r is actually your common ratio, which is less than 1. So here my assumption is the r is actually getting to be very, very, very small. So what happens is when it's a very small number, you multiply it, or you power it many times. What happens is this term here, and this is very small and this is very big. Okay, the values here will actually be approaching 0, almost 0. So now because of that, it's a very small value. So it's like considered insignificant. If you compare with A and your other values in it. So what happens now is, when this happens, your r power n is almost 0. So we are actually assuming, or rather deriving, the formula to become S infinite from here. N is infinite equals to A, because here is almost 0. So it's 1 minus 0. You get a 1 here. So 1 times A is A over 1 minus R. Right? Okay. So this is formula is actually derived from here. It's actually derived from here to this, and it's only applicable when r is less than 0, because if not, you won't have this assumption here. Okay, and this is known as sum to infinite, the formula, and it's only applicable for geometric progression, because geometric progression involves ratios. Ratios means division. Okay, so there are chances of you getting very big or very small numbers. All right, okay, so we move on with a few examples. Okay, now the question says find the sum to infinite. Okay, now for this formula is quite simple. Why? Because I only need A and I only need my R if I'm going to use this. All right, okay, so now to find my A, this is my A for my question. So A is 0.9 and my R is actually T2 over T1, 27 over 0.9. Okay, so you'll get about 1 here, so you get about negative 0.3. Okay, all right, you can just double check your calculator. Negative 0.27 divided by 0.9, you actually get, that's my R. So once you get your R, you want S to infinite, so this is A, formula is A over 1 minus R, which will become A 0.9 over 1 minus R, this is my R, 0.3. Okay, so what should actually get? 0.9 over 1 minus minus is 1 plus 3. 1 plus 0.3, which will become, okay, it's quite a big number, or you can just leave it in fraction. 9 over 13. You can leave your answer in fraction or use decimals. Alright? Okay, we take one more example. Let's say I've got 3, 2, 4 over 3 and so on. Okay, so here my A is 3. My R will become 2 over 3. Okay. So S to infinite is A, 1 minus R. A is 3. 1 minus R is 2 over 3. So here is 3. This one is 1 over 3. So you should get a 9. Alright? Okay. So that's one. Okay. One more question. Okay, now let's say the sum to infinite of geometric progression is 32. They've given you the sum to infinite. Okay, given the common ratio is 0.5, find the first term in the progression. So we want to find the first term in the progression. All right. So what is given to us, the sum to infinite, means this is given to us, 1 minus r. And from the question, they've given you the common ratio. First term is not given. So my common ratio is 0.5. And all of this is actually equivalent to 32. Okay, so A down here is 0.5 equals to 32. So A is 32 times 0.5. So A becomes 16. So that's my first term for the given progression. All right. Okay, one more question that you can actually ask you is something called recurring decimals. Okay, now recurring decimals, I'm sure you've seen this, we've seen it a couple of times. So when you're doing progression, okay, this is one symbol that you need to watch out for. Example, if you have 0.5, you've seen this is a normal decimal and you have like a dot up here. So means this digit 5 is actually recurring, meaning it's actually 0.5. Okay, then the next one will be 0.55. The next one will be 0.555 and so on. All right. Okay, so that means now my A from the progression is 0.5. My R will actually become 0.55 over 0.5. All right. So we'll get about okay, so what we can actually do is, this is my R. Okay, so from here, we find what's your R and we actually solve it. So, okay, another method of doing will be here. What we can actually do is, my first term is 0.5. Okay, my second term will be 0.05, 0.005. Okay, so this is another easier way of looking at it and so on. Okay, all right. Okay, so that means my A here is 0.5. My R is 0.05 over 0.5. Okay, so 0.05 over 5 will become 0.1. Alright, okay, so that means now my Sn, or rather S infinite, is A, which is 0.5 here. We don't use this method, this one is, we don't use this, alright? Okay, alright, so what you can actually do is A, which is 0.5 over 1 minus R is 0.1. So S infinite is 0.5 over 0. This is 0.9. 1 minus 0.1 is 0.9. So we change it 5 over 9. So that's the answer. Okay. Alright. Okay, we try for this one now, for this question. So my first is 0.8. So this 8 is your recurring. Okay, my second one is 0.08. Third one is 0.008 and so on. Okay, so my A is 0.8. My R will be 0.08 over 0.8. Okay, so you actually get 0.112, 0.1. So my S to infinite is A over 1 minus R. Your R here is 0.1. So 0.8 over, this is 0.9, so I get 8 over 9. Okay, alright. Okay, likewise here, if you have got something like this, these are my terms. Okay, you won't use this. This is a bit more complicated. We just use this easier. Okay, alright, so the first one is 0.15. Okay, second one is 0.0015, 0.000015, and so on. Okay, so my A is still 0.15. My R will be 0.0015 over 0.15, which gives you about 0.01. Okay, so that means my formula S to infinite will become A over 1 minus 0.01. Okay, so I get 0.15 over 0.99. So this is actually 15 over 99, or it can become 5 over 30. Okay, 5 over 32. Alright, so that would be the answer, 5 over 32. Alright, okay, yeah. Okay, this is one more question. Okay, now for this one, if you notice, only the 2 and the 6 are recurring. The 1 is not. So we'll just put it as this is the first question. So I put it as 0.1 plus 0.026. Alright, so now what happens is, this is actually 0.1, nothing happens. Okay, so we will start here, 0.026. Okay, now the next one will be 0.00026. Alright, and so on. Okay, so now for this is still 0.1. Okay, now for this, I'm going to use my S infinite formula. So the formula we know, S infinite is A over 1 minus R. Okay, so for this now, my A is actually 0.026 over 1 minus, okay, what's my R here? R will be 0.00026 over 0.026. Okay, so it's 0.00026 divided by 0.026. So I'll actually get 0.01. This is my R value here, 0.01. Okay, so I'm not using equal sign, this slipshot method. So this is 0.1 over 0.26 over 0.99. Okay, so what we'll actually get is, this one will be 1, 2, 3, 4, 5, 6. Just double check. 1, 2, 3, 4, 5 over 2, 6. Okay. Alright, so what we'll actually get is 1, 2, so plus over 99. Okay, so it's 0.1 plus 2.6 over 99. That gives you about, I use decimal, 0.1. 126. Okay, right? Or what you can do is you change this to decimal, fraction, sorry. So what you actually get is 26 over 990. So we get 14. If you want to change this to decimal, 13 over 495. Okay, plus this one here, if you were to change, this is 1 over 10. Okay, so plus 1 over 10 will actually give me 25 over 198. Okay, this is in the form of a fraction. So instead of this, because this is, notice this is the same as our question here, they would prefer us to change it or convert it to the form of a fraction. Okay, all right. Okay, so please look at this, and then I want you to try and complete skill practice 16, skill practice 17, and skill practice 18. Okay, a few questions. Please try. Thank you.